In this video, I want to do two things. Number one, I want to answer the question, what is the binomial distribution and when do we use it? And number two, I want to solve a binomial problem using only intuition. And through that, we're going to understand where the binomial distribution formula right here came to be. So what is the binomial distribution? It's probably a little bit easier to ask, what does the binomial distribution do for us? And here's what it does. It gives us the probability of getting a certain number of successes out of a certain number of tries. Let me give you a few examples. It can tell us the probability of getting 7 out of 10 shots on a basketball court. It can tell us the probability of rolling a dice 5 times and getting 3 fours. Or it could tell us the probability of getting more than 7 heads on 10 coin flips. In these scenarios, we're defining success as getting the ball in the hoop. We're defining success as rolling a 4. The important thing is our ability to categorize each trial as a success or failure. If we could do that, we can almost definitely use the binomial distribution to calculate it. The next step here is to solve a binomial problem, and I want to do that dice example because I think it's a really instructive one. All right, so the first question is, what is the probability of actually rolling a 4? Well, if we know we have 6 sides, we know that P, or probability of a 4, is equal to 1 out of 6. And this is pretty simple, but the probability of not 4, which is the same as the probability of anything else, is equal to 5 out of 6. So we are rolling 5 dice. Or you could say we're rolling 1 dice 5 times. It really doesn't make a difference. We're rolling 5 dice, and we want the probability of 3 fours. What's the probability that if we roll 5 dice, 3 of them turn up 4? There's going to be 5 different results. All of them are either going to be a 4 or not a 4. I know technically not a 4 includes 5 different results. It could be a 1, a 2, a 3, a 5, a 6. But for the sake of our problem, we're looking at this in black and white terms. It's either a 4 or not a 4. And any type of binomial problem, you have to look at it as either this or not this. It's black or white. So if we want 3 fours, that means we need 3 things to happen that have a probability of 1/6, and we have 2 things that are going to happen with probability 5 out of 6. So with probabilities of independent events, we have to multiply them to figure out the total cumulative probability. So if we multiply all of these things together, we get 25 out of 7,776. Now, we are not done. And the reason we're not done is because we just kind of decided that the first 3 dice would be the ones getting the 4s, right? These 3 are the ones with the 1/6 probability. So those are 4s. And these 2 are my not 4s. But we know that it could shake out differently. It could be that dice 3, 4, 5 could be the ones with the 4s, or it could be 2, 3, 4. There's a bunch of different orders that could get us the result that we want, which is 3 out of 5 of the dice being a 4. And the expression that we use to figure out how many different ways we could get 3 fours is a combination. It's like this: 5, choose 3. That's how it looks. Or it could look like 5, choose 3, like that. This is an area of math called combinatorics, and if you're not familiar with it, I made a video on it. I'll link it right above here. If you don't know how to calculate combinations, pause this video, watch my video on combinatorics, and then come back for the finish. Because we have to multiply this 25 over 7,776 by the amount of ways that we get our 3 fours. So 5 choose 3 is equal to 5 factorial divided by 3 factorial times 2 factorial, which expands to 5 times 4 times 3 times 2 times 1. which is equal to 10. So finally, we have 10 times 25 over 7776, which is equal to 250 over 7776, which is approximately 0.0322, which is approximately 3.22%. And that is our final answer. So again, the probability of getting 3 4s out of 5 rolls is about 3.22%. And the reason that we had to multiply this initial fraction by 10 is because there's 10 different ways that we could have gone about writing this out. Multiplying 3 1/6 by 2 5/6. Just to clarify this point of why we're not done when we get 25 out of 7,776, we could get our 3 4s here, here, and here, and then these are my non-4s. We could get them here, here, and here. We could get them here, here, and here. There's a bunch of different ways that we could get the result that we're looking for, which is 3 4s out of 5 rolls. So that's why we need to add up all the different ways that we could do this. And it turns out that there are actually 10 different ways we could do this, which is why we have to multiply it by 10. So hopefully that's clear to you. Now what I want to do is show the formula for the binomial distribution and show how it actually makes sense based on the work that we just did and how it actually explains the entire process that we just completed. So in order to understand this formula, we need to understand what P is, what N is, and what K is. P is probability of success. And in our case, that is 1/6. That's the probability of rolling a 4. N is the number of trials, which here we have 5. We're rolling 5 dice, or we're rolling 1 dice 5 times. Again, doesn't make a difference. And K is the number of successes we want, which is 3. So this, in our case, is going to be 5 choose 3, which again, use my combinations video, that's equal to 10. 10 times P, which is 1/6 to the K power. How many successes do we want? How many times do we need to hit this thing with a 1/6 probability? That would be 3. We need 3 4s times 5 6. Those are all my other results, or my failures. And we need how many of those? We need 2 of those. That's my 5 minus 3, or N minus K. So this formula actually describes the entire process that we just went through. And the one question that might be lingering is, back in the beginning of the video, I talked about 3 different examples of binomial problems that could be asked of you. What's the probability of getting more than 7 heads on 10 coin flips? Now for that one, you might think, now that one's a little bit different because K is the number of successes we want. We just want more than 7. So how do we input that? So the way we would do probability of more than 7 heads is we would need to do probability of 8 heads out of 10 plus probability of 9 heads plus the probability of 10 heads. And each of these gets its own binomial distribution formula. So you would have to calculate each one of these things independently and then add their results at the end. So that one is a little bit more involved, which is why I chose not to do that one in this video. I would be happy to do that one in another video. Thank you so much for watching. If you like this stuff, like the video, subscribe to my channel, comment, and just say hi. I am also offering private tutoring. Email me at aritutorsmath@gmail.com if you're interested, or if you know someone who's interested. Have an awesome day.